Okay, good day. We are back to discussions about an idea of what is CCR, referring to clustering, classification, and regression. Why these are important is, broadly speaking, about 95% of all data today, when I say all data today, it is all what you call AI, ML, deep learning, data science, etc., use one of these methods or techniques, whatever you call that. Okay, so more specifically I have labeled this as age of data, because we will see how all these play a role, because basically we have problems to be solved, problems that need solution. Now, where are these problems? Problems come from real world, even though today quite a few of them also come from virtual world. So, real world is interesting in its own way. We will see more of this. So, today you use words very frequently which say data driven. Of course, managers use this more, but when we say data driven, the idea is that you use data, of course, data related to a domain. This is very important, this idea of domain, which we will come to a little later. Use of data related to a domain to arrive at a solution, okay, or a response to a given task or a problem. Yeah, it looks a little abstract, but we will clarify these things now. Of course, you do have other words like data sciences, data analytics. These are buzzwords now. You really can't do much without using that, even though the meanings are quite different. Okay. What is relationship between data and problem? So, data and problem, after all, we are trying to solve problems, but we have hijacked it to focus a little more on data. So, the relationship is as follows. Okay. You are sitting in a real world. I hope most of you spend more time in real world than in virtual world, and the real world contains problems and issues of attention or interest. What we as citizens and more appropriately engineers or planners, whatever you call that, what we do is we attempt various approaches or methods and arrive at a solution. For example, the today's newspaper which tells that people who patched up all the potholes on the roads in Bangalore within 2 bouts of rain, there are now more potholes than what they were earlier. So, which means the approach taken for a real world problem of potholes on the road and the solution obtained is not satisfactory. Okay. So, more closer historically, this is very important because things have changed a lot. When you say you had a problem, there were 2 things about the problem. You had a model for the problem, typically a differential equation, PD, whatever, or your electromagnetic equations had vector calculus models. You had a model or you had a description. Many times you could not have done a physical or electromechanical model. So, you had a description about the problem, and based on that what you got was a structure for the problem. Which led to a solution when you attempted something. Okay. Today the same situation is little different. You actually collect data about the problem. And you do data analysis or even data models. This gives you a solution to the problem. So, let us reposition what it was all these days and days. So, you had a problem. You got, let us say, a good solution. How did you get in the past? You use very intelligent or analytical methods and got it. Okay. After all, everybody wants a good solution. In fact, they want more than a good solution. I will come to that. So, this is in today's term, this is equivalent to the problem, and you supply quality data. This is very important, quality data. You do simple data analysis and you obtain what is a good solution. The real difficulty is here. You rarely get quality data. Quality data is a question mark. Quality, and one can also use the word sufficiency, sufficient data. This is most difficult to get. It is like quality students and quality teachers. You have lot of students and lot of teachers, but getting quality teachers and quality students is difficult. The same is here. So, today the approach looks slightly different. It is as follows. You have a problem, and associated with the problem you get large quantity data on which you work qualitative methods to get a good solution. On good solution you can do optimization. Optimization so that you get a optimal, meaning the best solution for a given context and given So, you have a problem, you have large quantity data, you obtain qualitative and optimal techniques, and you arrive at optimal solution. This approach, this is what is called machine learning now. This is machine learning. You start with large quantity data because you do not get full quality data. You have to extract quality from quantity, and you do an optimization technique which will give you an optimal solution. And this machine learning has two components. One is the machine part, which has both a hardware architecture, it has systems which is both algorithm plus software. Then the third most important thing is domain knowledge. So, this is really the learning part. This is the learning part where it includes historical data which is also in some sense accumulated knowledge. These are used for interpretation. When you say interpretation, this is really the solution. Of course, the hardware architectures are now more familiar. You have the NVIDIA, you have the GPU and TPU which dominates. You have systems and software separately for that. Not only that, you do all this multi-threading, parallel processing, etc., etc. Okay. So, everybody talks about machine learning. What it really means is the following: data, which is quantity. Quantity comes from sensors and IoT, sensors and IoT, and from quantity data you extract quality, extract quality. This is the trick, because getting quality data, sufficient quality data straight away is nearly impossible. What you can get is adequate quantity, and today adequate quantity is available through sensors, and if you want streaming data, real time problems, IoT does that. Okay. Now, we will see how all these map to problem solving. After all, we are here to solve problems. So, you have real world problems that need solution. You start with data about the problem. There are various ways to this. You can collect the data, you can get data streamed, you can also access stored data, stored or legacy data. Now, all data, or all, when I say almost data, are of two kinds. So, you have data which have label. Label later is generically used, associated with the word called feature, or annotations, annotated. The other type of data is without labels. which means it is just data with no specific characteristic or feature. I will give you examples. Let us look at the eye issue. When you say eye looks yellow, so data about the eye looks yellow is a color. Immediately it is easy to infer that this is in the healthcare. So, the domain is healthcare. When you observe, that is very important word, observe. Observe the eye, it looks yellow. This is a case of jaundice. It is almost a unique label. On the other hand, you take a situation where you are looking at general fever, right. There is no unique label, there are a dozen reasons for fever. So, fever as such is unlabeled data, whereas yellow eye is labeled data. So, you have data which is labeled, other extreme is unlabeled. There are other categories, partially labeled, incomplete, obscured, so many things, we will not worry about them right now. So, two broad groups, labeled data, unlabeled data. Take another example also related to the eye. Okay. So, you have a red color eye, red eye. You have half a dozen reasons for this. Dust, some insect may have infected, you may have got slightly injured, etc., etc. So, no unique label. On the other hand, a problem related to eye, let us say glaucoma eye, here you see patterns in iris. So, what you recognize glaucoma as patterns. This word pattern is important because machine learning is equivalent to recognizing patterns in data. This is one other thing, one other approach for machine learning is ability to recognize patterns in data, and I gave you an example from glaucoma. There are others, for example, your DNA analysis. You have long strings of data. Long strings of data. In between each, you recognize specific or characteristic patterns. In fact, humans 90% of our tasks relate to pattern recognition, or more appropriately pattern processing. not data processing per se. And this is interesting because out of million data points, million data points, a solution may just be a pattern of data about few thousand. So, this is really what it is. It's almost like a needle in a haystack problem, needle in a haystack. So, you have a haystack of data and the machine learning will pick the needle in that. That is really how most of these things work. So, how do we actually solve? How do we actually solve? We are solving the problem. So, you have a problem which needs solution, Today the problem needing solution is equivalent to large volume, quantitative data about it, about the problem, is it? Large volume or quantitative data related to the problem is what we are actually looking at. We want to solve this, but we start with this. So, hopefully, when we do something on this, it amounts to solving the problem. As we said, there are two kinds of data. One data is unlabeled. The other data is labeled. So, when you have labeled data, from labeled data you can extract and select features. As I said, you have lot of eye data, and one eye data there is yellow color. So, that is labeled. So, once you have, why I am saying extract features, not necessarily all features are used, you will make a selection depending on the task, and if it does not work out, you may have to change. We will come back to that later. Now, from once you have selected the features, based on the features you can either design or select a classifier. For example, you have all eye data, plenty of eye data, and in the, if you do a careful selection of features, you can find something which says all these eyes are yellow, these are not yellow, they could be even be red, not yellow, and then you find a hypothetical line which separates all eyes into two categories, yellow eyes and non-yellow eyes. This line is called a classifier. separator. Okay. It is not just easy to select a classifier, you have to train the classifier. I will come to this, train the classifier. After you train the classifier, you have to test the classifier. Check the result. If the result is okay, that is equivalent to solving the problem. If the result is not okay, then many things can be done. For example, you can go back and change the feature, you can go back, change the classifier, you can even relook at training methods, so on. Okay? Basically saying I have labeled data, so I will do this iteratively. I can even change the type of classifier, I can take different type of classifiers and do fusion, so that I get a solution which is acceptable. This is for the labeled data. What about the data which is unlabeled? Okay. Since you do not have features, labels, what you do is you do what is called clustering methods. Cluster the data, and large number of clustering algorithms are there. So, the clustering algorithms is equivalent to saying birds of the same feather, birds of the same feather flock together. You see this, let us say a typical party where lot of people, many unknown, everybody comes there, but after some time people with similar or common language group themselves together, right, and this also happens in any cosmopolitan atmosphere like a college hostel during mess, where new people cluster together who either share the same language or something like that. Okay. So, clustering is as common as classification in real life, which we do. Okay. So, that is the reason why this method is very popular and it works well. So, you cluster the data, you get clustered data. Now, the question is how many clusters, we will come to that. So, clustering the data is done through what is called the clustering algorithm or clustering methods or clustering algorithm. Now, from the clustered data you can tentatively pick a label. For example, people group together and you may pick one language, a South Indian or a North Indian language as one label for that group, which we did not know earlier. Okay. So, once you have a label data, the technology proceeds to do this, extract the features, put it to a classifier, etc., and go. Now, same thing, if the result is not okay here, the other interesting thing is you can actually do this resample. Suppose all the techniques do not work well, maybe you can question the source of the data itself or relook at it, like what is happening now for in some constituencies repolling is held, many times resampling is done. So, all these things are part and parcel of the process of machine learning today. Okay. So, we will summarize for the intermediate stage. So, you have data. If the data is labeled, you do classification. If the data is unlabeled, you do clustering methods. And there are half a dozen clustering methods, there are a dozen classification methods. More importantly today, there is something called fusion strategies. What are these fusion strategies? You will do what is called a panel of classifiers. Panel of classifiers means taking answers from 2 or 3 classifiers and then taking a fusion as a final answer. We do that basically in healthcare and in legal issues. Healthcare and legal issues. There is something always called second opinion. So, second opinion means you take opinion from one, take opinion from the other, and then either combine or disregard one or fuse 50% weightage from both, then take your decision. This is the reason why many interviews are generally held in a panel. You will have a panel against which you sit down and multiple people question you in multiple ways and elicit different features about your personality and professional competence, and then take a fused opinion. This is very natural. Okay. Yeah, in the next session we will look at clustering methods and classification techniques in detail.